Hello, this is Scott Strive doing some math today in geometry. We're going to be looking at proving triangles congruent instead of by SSS but by SAS and HL. So SSS stands for side, side, side. SAS stands for side, angle, side. And not just any angle, but the angle in between, and I'll show you an example. I was doing it. So let's imagine that these two triangles are congruent. What I'm trying to show you here is ABC, DEF. So what we need is two sides congruent. Let's use colors here. Actually, so these two sides need to be congruent. Well, it doesn't have to be that particular two sides. Any two sides need to be congruent. And the angle in between. So the angle in between here is B and E. So not only those two sides need to be congruent, the included angle, or the angle in between, needs to be congruent as well. And then HL postulate, HL postulate stands for hypotenuse leg. So if you have a right triangle, and we know that the hypotenuse, so hypotenuse is the longest side of a right triangle. So if we know that the hypotenuse are congruent and one of the legs, so in a right triangle, let's draw it out here, we have the hypotenuse and then two legs, usually a long leg and a short leg. And then we have a right angle. So if we show that the hypotenuse and one of the legs is congruent, then the two triangles are congruent. Okay? Let's do a proof. Okay, so they say that Jn is congruent to Ln, and Kn is congruent to Nm, or Mn. Okay? Prove that triangle JKN is congruent to triangle LMN. So left equal right. Or left congruent to right. Statement. Reason. 1. So Jn is congruent to Ln. Given. And let's also just tack on Kn is congruent to mm. Kn is congruent to mn. Okay. So those are given. So 2. So we need to prove that these triangles are congruent. We now have 1, 2. So we have SSS, we have SAS, we have HL, and then we can prove that all the other pieces are congruent. So there's 4 different ways. Most likely we're going to use one of these 3, but mostly we're probably going to use SAS because we have 2 sides, and then they hint at 2 angles here, angles 1 and 2. And we know that angles 1 and 2 are congruent because vertical angles. Vertical angles are congruent. Definition. There we go. If angles are vertical, then they're congruent. 3. We now have all our pieces for SAS, so I can just say triangle JKN is congruent to triangle LMN. SAS. So one side, what's from the first statement, JN is congruent to LN. The other side is from KN, MN. And then the angle in between, or the included angle, angles 1 and 2. That was the second statement, so I can just say SAS. ABCD is a rectangle. What can you conclude about triangle ABC and CDA? Okay. We can conclude that triangle ABC is congruent to triangle CDA. Why? Because it's a rectangle. Rectangles, opposite sides of rectangles are congruent. That means AD is congruent to BC, and then AB is congruent to DC. And we know that the four corner angles are right angles. But in this case, all we need is the right angle there. Because we can use, so angle D is congruent to angle B. So you can use SAS or you can use HL postulate, either one, because these are right triangles. We can even use SS because AC is congruent to AC. So that's all three pieces there. Okay, here we go. Let's do another proof. AC is congruent to EC. AB is perpendicular to BD. So guess what? That's going to make a right angle here. And ED is perpendicular to BD, so that's going to make a right angle there. And AC is the bisector of BD, so this is technically a midpoint. Alright, here we go. So here we go. So statement, reason. And to save some space for myself, okay, you're going to put all of this into your first or statements 1 through 4, or your just first statement, and the reason behind it is given. Okay, so always put down your given. Alright, 2. So I said those angle B and angle D become right angles. Angle B and angle D are right angles. Okay. If two segments are perpendicular, then they intersect to form right angles. Okay. So even though they're both right angles, we need to say that they're congruent. Angle B is congruent to angle D. And then we can just say right angles are congruent. Right angles are congruent to each other. Alright, so we have one side, we have a right angle. Normally, if you ever see a right angle with triangles, it's going to be HL postulate. So we already have the hypotenuse. that was given. They tell us one more thing in our given, that AC is a bisector of BD. That means BC is congruent to CD. Okay, and that's because, well, I don't have any more space. Where's my, there it is. Okay, so BC is congruent to CD because definition of a bisector. So if a segment is bisected, then it is split into two congruent parts. So if a segment is bisected, then it's split into two congruent parts. Okay, now that we have all our pieces, we can finally say that the two triangles are congruent, which is, why can't I move this? ABC, EDC. So 5. Triangle ABC is congruent to triangle EDC. And that's by the HL postulate. Hypotenuse leg. Okay, so let's review again. Trying to. Oh, okay. Well, anyways, so you always start with your given. So they tell us that AC is congruent to EC, and they tell us that those are perpendicular. So because those are perpendicular, they form right angles. So that's where I got angle B and angle D are right angles. AC is a bisector of BD. That means these two segments here are congruent, BC and CD. So now that I have a hypotenuse leg and we know that this is a right triangle, we can show finally that that these two triangles are congruent. Okay, example 4. The gate to a ranch is a rectangle. You know that triangle AFC is congruent to EFC. So this is congruent to that. These are congruent to that. And those are congruent to that. How can you conclude that ABC is congruent to A? Okay, so they want the upper left triangle. They want to know if the upper left triangle is congruent to the upper right. Okay. So we already know that AC is congruent to CE because the other two triangles. So that's one piece. So AC is congruent to CE. Okay, that was because the two triangles the two bottom triangles are congruent. Okay, now we know that also that AB is congruent to DE. So AB is congruent to DE because opposite sides of rectangles. Okay, and we know that the corner there is a right angle. So angle B and angle D are right angles and congruent. Okay, because that's another property of a rectangle, is that the four angles in the corners are right angles. So HL Okay, checkpoint 1. Explain why the diagonals of a rectangle always forms two congruent triangles. So once again, opposite sides of a rectangle are congruent. So you got that piece congruent to that piece, and then that piece congruent to that piece. And then when you put the diagonal in, the third side of the triangles are the same. So SSS. Because opposite sides of the rectangle are the same. And then the third side, when you put that in, the diagonal, it's congruent to itself. So the two triangles are congruent. In example 4, suppose that you know that ABCF and EDCF are squares. How can you prove that ABC is congruent? So ABC, so the top left again, to EDC, top right. Well, I meant, if you know that they're squares, I'm going to skip ahead on this one, but basically, so let me erase the picture. So let's assume that A, B, C, F, and so, okay, these are squares. Those are squares. Okay, so that means these are all the same. Okay. So how the reasoning would go is that you would say CF is congruent to CF because of reflexive property. And you would say BC is congruent to CF because of the square. And since DC is also congruent to CF, so BC, CF, they're all congruent to each other. And then you would use the same reasoning to show that BA is congruent to DE. So you have two sides there, and then a special thing about rectangle or squares is that that the corner is still a right angle, and then you would use SAS. And that's all I have for you today. Sorry I couldn't work that fully out. So let me do it one more time. So example 4, suppose that you know that those are squares. Could you prove that ABC? Like, yes, you can. Okay. So we know for a square, all the sides are the same. Okay. And I would say that BC is congruent to CF because all the sides are the same in the square. And then I would say DC is the same as CF because all the sides in this square are the same. And since those two are congruent to the middle one, they're congruent to each other. And then you would use that same reasoning on A, B, and DE. So you would have two sides of a triangle are congruent, and then you would use SAS because these two angles are right, and that would show that they're congruent. Okay, that's all I have for you today. Good luck.